Okay, so let me go ahead and share my screen. Um, what we are going to be working on this week for week 3 is um, a topic called addition and resolution of vectors. So in some of the classes, you may see a force table experiment. So just in case this happens to get to you guys at a later year, subsequent year, we tend to label these a little bit differently depending on where you are. But virtually, we're going to call this addition and resolution of vectors. And so what you'll see here is a document that's in the course content area. And let me back you up just in case. So under course content, by now you should have gone in there already to complete your survey, to select the group that you're going to be working with for this and several other experiments down the line here in the next couple of weeks. The document again is addition and resolution of vectors. So that's experiment number 3. So you'll see this web page that just popped up. All right, so for this lab, for this experiment, what you're going to want to do is you're going to want to make sure that first off, your group adheres to the directions and the components of this next lab report. So it should be in your syllabus. So that's what I'm stating right there in the first sentence. And you're going to answer the questions that are going to follow here on this page, and submit to the Dropbox. Okay, so you're going to try and submit one single one file. And what I'm saying by multiple pages in a single file is you don't want to scan a page, submit it, scan a page, submit it. You want to collect those all as one single file. I believe that the Dropbox is set up so that there's only one submission for one file. Multiple pages is fine. And some of you guys may have done that in the first 2 experiments, depending on how I have that Dropbox set up, but it's very difficult for me to grade when I have to go in and out of a document. So I like to just kind of scroll through because I'm grading this on my computer. All right, so the first video that I suggest that you watch, it's probably not going to show up properly. So what you're going to need to do, you can do it one of 2 ways. You can do a right click and open in a new window or a new tab. So let's do that. And what this does, it takes us to YouTube. And of course it shows.
Okay, I'm gonna call now.
Skip the ad. And this shows you basically how
For
to
the
work
next bit
the
of the lesson.
simulation that we're going to be playing around with here. We're going to be utilizing. All right, so that's going to kind of get you started. And then here's the link to the actual simulation. Again, you're going to either have to right click it and open a new window. The other thing you can do is you can copy and paste it. So what you can do is just simply highlight it, go right click, open new window or tab. But that basically does the same thing that we just did a second ago, and then you can paste it in here. And it takes you directly, it should have taken you directly there, but I think I have the other URL set up properly. So there's the simulation that we're going to be working off of. And so let me put these things side by side. We're going to look at the simulation in just a second. This is going to be due on by February 16th, 11:59. So it should give you plenty of time to get through this bit of information. And I say, and I've probably said it before, if somebody is not contributing, you do not put their name on this document, okay? Because I'll check, and you guys are gonna all get the same grade for the next couple of weeks. So make sure you follow the directions, and again, be an active participant in your group. And so what you're going to try and do here is you're going to try and learn to resolve or decompose a vector into we call them sometimes IJ components, or sometimes I hat, J hat, or even X hat, Y hat components, which you're probably learning in your lecture class as well. And you're going to want to begin reading your lab manual in case you're a little bit rusty on how vectors work. And how you're going to use your lab manual is going to be based on a table that I've tried to recreate. You'll see it in just a second. And so I say here, I would not recommend trying to fill in the cells of the data table. When I say the data table, I mean the data table in your book by just simply writing through it. Rather, you're going to need to kind of copy and paste and recreate the table. And I've kind of done that below here, but you're really not going to be able to see the cell structure here. But this is a table. It's a 1, 2, 3, 4, 5. Looks like I have about 6 columns and I don't know, maybe about 10 rows. But this is just a recreation of the table that you see in your book. And so what you're going to need to do is you're going to need to answer the questions. Right. So for the graphical part of this, you're going to want to use a separate area and draw these vectors using a straight edge, right? Like a ruler of some kind, even the edge of a piece of paper to help you draw straight lines. Now, preferably, as I'm looking for my ruler, I can't find my ruler right now, but preferably you're going to want to use a ruler so that you can draw things to the proper scale. For example, if we're going to represent a force of, let's just say, 2 newtons, you're going to want to draw it such that it fits on your piece of paper, and it looks proper relative to another force, maybe one that is of 4 newtons. So maybe my 2 Newton force is, say, 2 centimeters. And so my 4 Newton force should be twice as long as that. And so we want to draw those to scale. And so here is our second video. I think this is one that I recreated. So yeah, this is one that I would recommend that you look over. It was done a couple years ago during the pandemic, so apologies for anything that looks a little bit sloppy here. And
do you love Gantt charts?
It's basically me writing on a simulated whiteboard. So again, it was during the pandemic. Everybody was scattering, and but it's a good use. Most students find it very helpful. Okay, and it talked about, I think, all three parts of this lab. Except the experimental, sorry, the 2 parts. So for the experimental portion, this is where you're going to use that simulation that I just had up here. So let's pop that back up here real quick. Get that back. So while this thing is loading, I'm on another screen, but I think we better put both of them up here so you can follow along here. You can get an idea of what I'm looking for. So let's just say that we're looking at vector addition 1. So it's probably not going to show up very well here in the in my courses. So you're gonna definitely want to redraw this. Somebody's gonna want to recreate this either in Excel or some other graphical version that you have in order to create tables. So what you're going to want to do is, let's see, I think I said to use so you're going to want to use probably the lab portion of this. And basically what you're going to do is you're just going to take a vector of some length and of some direction. So let's use this one, for example, right? And now this is really important to know, because all these abbreviations, this is why I really stress that you write down what all your abbreviations stand for. So G in this situation does not stand for grams. It implies the force due to gravity. So that's the 9.8 meters per second. Look at the video, you'll see what I'm talking about, right? And N is the nomenclature or the abbreviation for newtons, right? And so really I should have put that down here, and I'll make a note to myself that I should put that in there, because if I'm gonna hold you guys accountable, I need to hold myself accountable as well. So we have two forces here, one at about, let's just say that this is about 2 newtons, right? 0.2 times G. G is roughly about 10, so let's just say it's about 2 newtons, and it's going to be at around 30 degrees in direction. So what I'm going to do is I'm going to grab one of these vectors, and I'm going to draw it. Let's just say my 2 newtons, I'm just going to make this up, is about yay long. So for me, that's 2 newtons. Because if you scale it too far down, right, you're probably not going to get anything that you'll be able to see. So this is not the most precise. If you happen to come across one that's better, I'm sure there are some out there, and I probably need to look for some more. Let us know. So let's just say that I grab a vector, and instead of, again, 2 newtons, I make it 10 newtons, right? Or to be even more precise, 20 newtons, right? And so I've created my length here. If you look right here underneath the magnitude, you can see 20 newtons. So this is scaled up by a factor of 10, right? So the second thing I need to do is show its direction. So I'm going to kind of tilt this to about 30 degrees. Again, not the most perfect, but we can get pretty close. So that's about as close. And you'll notice that as you start to turn this thing, the magnitude is going to change slightly as well. So I'm going to just try and get as close as I possibly can. So let's just say that for time purposes, right? And then my second vector, which I'll call F2, is of the same length. So let's see if I can grab another one, right? So, and then I'll stretch it out, same length, roughly. And then, but this time it's going to be tilted or turned in a direction of 120 degrees. So relative to the x-axis, right, is 120 degrees, but I'm going to want to add these vectors, right? So I'm going to take this one, and I'm going to turn it as such, and I'm going to kind of run out of room here. That means I'm probably going to need to scale down a little bit, maybe cut it down to half its length. Okay, so the sum of these two vectors is going to be my resultant vector. And so you can see, let's see if I were to put one more vector in here. So there is my resultant vector. So it looks like my resultant vector is about 26 newtons, which is a scaled up by a factor of 10. So about 26 newtons and about 72 degrees. And its X components and Y components are 8 and 25. And you can look at this another way. So what this does is it shows values, it shows the sum, right? And it shows directions. So play around with these various labs in here. There's another one that you can play around with as well. You can take a couple vectors. Here's one, its magnitude. Here's another, right? And while I'm drawing this, it shows me this vector, which is the sum, as I'm drawing this, okay? So you can kind of do a little bit of playing around here, and you may not even need to use the tip to tail method if your vectors don't fit on here, right? So you can put a vector here, let's just say here, maybe your second vector, as in our situation, maybe went off the scale, right, a little bit. So what you can do is you can just take the vector, draw it as such, and it's at the same time the computer is actually drawing the resultant vector, right? So you don't have to necessarily use the tip to tail method, right? Because it looks like it's going to kick us off here, right? It just, well, in that situation it didn't, and because it didn't go by the text box, but there's your resultant vector. So play around. This is an experiment. You want to experiment. I don't want to give away everything here, but experiment in the simulation. Experiment as a group, experiment individually. Let people know in your group what you figured out, what you discovered. This is what science is all about, okay? And so for this table here, what I'm looking for is I'm looking for 3 different areas. So I'm looking for an area, actually it's not going to be in this table. For the graphical part, you're going to want to create your own little section, right? For the analytical part, the same thing. But for the, for the graphical part, you're going to want to put the graph that you've drawn in here. So you're going to just kind of draw it in here. For the analytical part and the experimental part, you're going to want to put it in a separate area because it's going to look a little bit messy. So I'm not really particular, but you really don't want to have graphs inside the table because it's going to show up a little bit too small, okay? And then there's 3 or 4 other areas in here that you're going to need to go through, right? And then you're going to need to look at your lab manual for these answers. So when you submit this, let's just say you recreating this table, you're going to delete this area out here that I have highlighted. So please don't keep this information in here that I'm saying copy and paste. So please delete those areas, okay? And so there's another, well, this is the same video here, as I said before, in that YouTube video that I've done in my house. You'll see a drawing, or it walks you through how to get the graphical and the analytical portion. The experimental portion, how do you find the sum of 2 vectors or 2 forces? We're going to do, that was the simulation. If you were in class, what we do is we put 2 forces on a force table. You have 2 masses strung together, and you try to figure out what the counterbalance of those 2 forces are. Okay. All right. So that is it in terms of the explanation of this experiment. I will be tuning you guys in next week. If you have any questions on this, it's probably going to be a good idea for, if not the entire group, or at least one of you guys to get together with me to make sure you guys have a clear understanding of what's going on. Over the next couple days here, I'm going to be submitting your your grades for the first two experiments, so you can look at that so that you can get some feedback and utilize that feedback to help you with getting your lab report right. So yeah, we should be good over the next couple of weeks. And if you have any questions or concerns, feel free to give me a call or email me. Phone number is 727-791-2503. Take care.